Hi children, today we are going to start the first part of the lesson, integration. Before we start to learn integration, we should know what do you mean by integration. In previous video, hope you have watched my differentiation videos. If you differentiate any function, you receive its gradient function. The opposite operation of this differentiation is integration. That means if you integrate a gradient function, you receive its original function. This is only part of an application of integration. There are many more. We will understand all the concepts about integration in future videos. Before we start integration, we need to understand the integration notations. The first notation, that is the integration mark with variable dx, that indicates you that you can integrate only x terms. If this integration variable is t, you can integrate only t terms. For example, if you integrate x to the power 10 dx, it's a possible operation. Therefore, the function to be integrated is in terms of x and the differentiation variable also x. But if you come up to the last example, that is integration of t to the power 10, whereas integration variable is x. Therefore, that operation is impossible. Now, let's start up with integration rules. Rule number 1. It is same thing as differentiation. If you integrate x to the power n, the answer is x to the power n plus 1 divided by n plus 1. But remember children, this formula is not applicable for n is equals to minus 1. We will understand the situation where n equals to minus 1 in future videos. For example, if you integrate x to the power 5, now you can understand n is 5. Therefore, the answer would be x to the power 5 plus 1 divided by 5 plus 1. Then the answer is x to the power 6 over 6 plus c. This c is an additional constant we added to this expression. Later on this video, we will understand what is c and how to find the value for c. Let's verify the rule number 1 from another example. The question is integrate x to the power 12 dx. There n is 12, therefore your answer would be x to the power 12 plus 1 over 12 plus 1. Final answer is x to the power 13 over 13 plus c. Now let's discuss what happens if n is equals to minus 1. If you integrate x to the power minus 1 dx, the answer is x to the power minus 1 plus 1 divided by minus 1 plus 1. Therefore, answer would be x to the power 0 over 0. We know that we cannot divide any number by 0. Therefore, this answer does not exist. In future videos, we will try to understand how to solve this integration of x to the power minus 1. Let's try to understand rule number 2. Rule number 2 is if there is a constant added to x to the power n, how to do this integration. It's pretty simple. As same way what we did in differentiation, take this k out of this integration form. That means integration of k x to the power n dx turn up into k times of integration of x to the power n dx. Then you can simply integrate x to the power n dx and multiply with k. For example, integration of 7 times of x to the power 5. We can simply take this 7 out and you can write 7 times of integration of x to the power 5. Your answer turn up into 7 times of x to the power 5 plus 1 over 5 plus 1. Then final answer is 7x to the power 6 divided by 6 plus c. Remember children, it's compulsory for you to add a constant c at the end. Let's try to verify this theory from our second example. The problem is to integrate minus 3x to the power 12. From this integration you can take this minus 3 out and you can write it as minus 3 integration x to the power 12 dx. Then you can simply apply the integration format for x to the power 12. Your answer turn up into minus 3 times of x to the power 12 plus 1 over 12 plus 1 plus c. Final answer is minus 3x to the power 13 over 13 plus c. Let's try to move into rule number 3. Rule number 3 is if you integrate few expressions separated by additions or subtractions, you can integrate them separately and you can make them additions or subtractions as mentioned in the problem. For example, if you integrate 5x to the power 3 plus 6x to the power 2, you can understand that 5x to the power 3 and 6x to the power 2 is separated by a mark of addition. Therefore, you can integrate 5x to the power 3 and 6x to the power 2 separately and you can add them together. Then your answer turn up into 5 times of x to the power 3 plus 6 times of x to the power 2 using the second rule. Using the first rule you can say 5 into x to the power 3 plus 1 over 3 plus 1 plus 6 into x to the power 2 plus 1 over 2 plus 1 plus c. Then your final answer would be 5x to the power 4 over 4 plus 6x to the power 3 over 3 plus c. There is one more thing we have to be verified. These operations or this rule number 3 won't be applicable if these functions are separated by multiplications or divisions. Let's try to verify the theories from another question. In this question, we have to integrate 5x to the power 3 minus 6x to the power 2 plus 7x. Using rule number 3, you can separate these terms as integration of 5x to the power 3 minus integration of 6x to the power 2 plus integration 7x to the power 1. Using rule number 2, you can take this constant out and you can write 5 integration x to the power 3 minus 6 integration x to the power 2 plus 7 integration x to the power 1. Then if you apply rule number 1, you can get the final answer 5x to the power 4 over 4 plus 6x to the power 3 over 3 plus 7x to the power 2 over 2 plus c. As I mentioned in the previous slides, if you integrate ax to the power n into bx to the power m, you can understand that these two x terms are separated by multiplication. Therefore, you cannot write it as ax to the power n dx into bx to the power m. For example, if you want to integrate 2x to the power 4 into 3x to the power 7, you cannot write it as integration of 2x to the power 4 into 3x to the power 7. Same concept valid for divisions also. You cannot integrate ax to the power n divided by bx to the power m as ax to the power n divided by integration of bx to the power m. The same example indicates the same concept. This is one of a very popular mistake where most of the students do. They think that integration of 3 over x to the power 4 is equals to 3 divided by integration of x to the power 4, which is exactly wrong. Then how do we supposed to do this question? If you want to get integration of 3x to the power 4 using indices theorem, you can convert into a form of integration of 3x to the power minus 4. Then you can use the first principle and you put into the formula x to the power n integration and you can get the answer 3x to the power minus 4 plus 1 divided by minus 4 plus 1 plus c. Then your final answer turn up into 3x to the power minus 3 over minus 3. The next concept is how to integrate a constant. As mentioned in the problem, we have to integrate k dx where k is a constant. For example, integration of 10 dx. If you had a constant to be integrated, you can write that k as k into 1. We know that any variable to the power 0 or any term to the power 0 is 1. Therefore, instead of this 1, you can write x to the power 0. Therefore, this integration of k dx turn up into integration of k x to the power 0. Now you can take this k out and you can integrate x to the power 0 and you can obtain the answer k times of x to the power 0 plus 1 over 0 plus 1, and your final answer is kx. As mentioned in the example, if you integrate 10 dx, your answer would be 10x. And then you can remember at each and every integration we have added a constant c at the end. At the beginning of this video, I told you that we'll be discussing the use of having this c into an integration function. We know that the integration is the opposite operation of differentiation. If you differentiate any function, you get its gradient function, and if you integrate that gradient function, you should get the original function. That means after the integration, you should be able to get the original function at the beginning. As shown in this example, if you differentiate x to the power 3 plus 3x squared minus 25x, you receive the answer 3x squared plus 6x minus 25. Therefore, if you integrate 3x squared plus 6x minus 25, you should receive the answer x cubed plus 3x squared minus 25x. Refer to this example. If you differentiate x to the power 3 plus 3x squared minus 25x, you receive the answer 3x squared plus 6x minus 25. The same way, if you differentiate x cubed plus 3x squared minus 25x plus 5 also, you get the same answer, 3x squared plus 6x minus 25. Therefore, if you integrate 3x squared plus 6x minus 25, which answer you receive? Whether it's x cubed plus 3x squared minus 25x or x cubed plus 3x squared minus 25x plus 5. How do we get the both answers at once? That is why we add a constant c at the end of the integration. Later on, we will discuss how to find the value for c in such question. Hope you have enjoyed my video. Thank you.